Okay, welcome to the third video in the categorical logic portion of the course. And in this video, I'm going to pick up the exercises we did at the end of the last video. We're also going to discuss the modern and traditional interpretations of empty sets, and we're going to go through the concept of the distribution of terms. So that's our agenda for today. Just remind ourselves what these direct inferences are. These are the relationships between statements in standard form that are given with the same subject and same predicate, but have different quantity or quality. So that if we have all snakes are poisonous, if that were true, that would automatically imply that some snakes are not poisonous would have to be false. It would also mean that it cannot be the case that no snakes are poisonous, and it would also mean if all snakes are poisonous, there is at least one snake that's poisonous. And as you work around this square, you can make direct inferences. We talked about that last time. And so when we have something like contradiction, contrary, and subalternate of all students are hardworking. Okay, so let's just keep that all students are hardworking in mind. We'll come back here. All students are hardworking. The contradiction would be some students are not hardworking. The contrary would be no students are hardworking. And the contrary would be some students are hardworking. Sorry, that's the contrary. This is the alternate. Some students are hardworking. The next one, no faculty are present. So we have no faculty are present. We're just swapping in our new subjects and predicates. So the contrary would be all faculty are present. The contradiction is some faculty are present. The alternate is some faculty are not present. Next one, some fiddlers are great. So that's this form. Some fiddlers are great, swapping in a new subject and predicate. The subcontrary, remember the ones on the bottom are subcontraries. Subcontrary is some fiddlers are not great. Contradiction, no fiddlers are great. The alternate is some fiddlers are great. It's really that simple. You just find your way around the square. The last one is some violinists are not great. So that would be this form is where we're starting. So we have violinists are not great. So the contradiction would be across. All violinists are great. The alternate would be, or subalternate would be, no violinists are great. Subcontrary, some violinists are great. So, and there's plenty of exercises in sections D and F of your text. And if you are using an alternate text, look up in the index direct inference and then do whatever exercises that textbook might associate with that. Now, all that being said, there is a subtlety here we need to pay attention to. And I spoke to this last time when we talked about empty sets for the first time, which is that the Greek language and the Greek state of mind when this logic system was invented didn't worry too much about empty sets, right? Dragons over the hill, gods that can shoot thunderbolts, you bet they exist. They weren't all that skeptical about things in the way that maybe our society is. So the traditional logic system presumed that every set had at least one member. So looking at this statement, all the present kings of France are bald. Well, how many present kings of France are there? There are none. And so to say, what's the truth status of all the present kings of France are bald, it's rather hard to say. And we could get that's a rabbit hole we could go down very quickly. But notice that if we just followed this statement around the square of opposition, if it's true that all the present kings of France are bald, that seems to imply the alternate that there is some, meaning at least one present king of France, are bald. Well, it also implies there's at least one present king of France that's not bald. So what's up with that, right? This at least one claim describing a set that we know is empty is a little bit concerning. So if there is a possibly empty set, then the only logical direct inference that works is contradiction. And so now let's talk about how we're going to handle this. So the traditional or the Aristotelian interpretation of empty sets is to assume there are no empty sets. And if you had a statement that had possibly an empty set, unfulfilled existential import, so a statement like all dragons are greedy, the way we're going to interpret that is to say all dragons, and there is at least one, are greedy. And since there are no dragons, that statement then becomes false because it doesn't fulfill this implied portion of the statement. The modern or Boolean interpretation, George Boole is a big guy in the logic world. Boolean logic, named after him, for those of you who might be learning that in computer science. So, what's the deal with empty sets? According to the modern interpretation, no problem. And the way we're going to interpret empty sets is with this little phrase, if any. So, all dragons, if any, are greedy. And then, so that statement can be true even in a fiction book, right? If we all agree that according to typical sort of fantasy novel standard material that dragons are inherently greedy, then even if there are no dragons, that can still be true. And so for some interpretations, this is going to be a better way of thinking about it. And so what we're going to need to do is rely on context to determine whether an empty set is a problem or not. So looking at this statement here, all trespassers are prosecuted. The point of putting that sign up is to attempt to create a situation in which there are no prosecutors or there are no trespassers. You're putting up, and if you put up that sign at the end of your driveway saying all trespassers are prosecuted, you'd really rather you had no trespassers. You're not wanting that, you're trying, in fact, to create the condition in which that is an empty set. So, but at the same time, that what looks like an ad baculum fallacy, that's another problem for another day, I would argue that all trespassers are prosecuted is a true statement, even if it's an empty set. And so that if any interpretation is clearly the right way to think of that. If I make the claim some students are going to pass the test, by the way, we have one coming up, it would be kind of a crazy thing to say if I had no students. And so and there is at least one is clearly the plausible interpretation. Some students, if any, are going to pass the test. Seems kind of weird. Some students, and there is at least one, are going to pass the test. Why would there be a test if there was no students? Okay, so we're relying on context, the principle of charity for interpretation here. and you try to use an interpretation that leads to the argument working if possible, if it's as a part of an argument. And so on the Boolean interpretation of if any, the only direct inference that works is the contradiction. And maybe I should speak to that a bit more, because the contrary is one people seem surprisingly fond of. They don't want to see that disappeared. So let's talk about that. Looking at these two examples, all sea monsters are dangerous, and no sea monsters are dangerous. Okay, so this is an A and an E form of the same subject and same predicate, so they're contraries. Now, the definition of contrary was two statements cannot both be true. So if we interpret it in the traditional way, where all sea monsters and there is at least one are dangerous, and no sea monsters and there is at least one are both false because there isn't at least one. So that works. The contraries work on the traditional interpretation. Now, all sea monsters, if any, are dangerous, and no sea monsters, if any, are dangerous, somehow end up both being true because there isn't one. And so the contraries don't work if you think that an empty set is okay, and you're going to default to true, or you don't have an automatic way of saying it's false just because it's empty, I guess is really what the problem is here. So pay attention which interpretation is appropriate. And then when we get to learning the rules for syllogistic logic, we're going to realize that we're going to need an extra rule in our system to accommodate the potential of empty sets. Next concept, a very critical one for syllogistic logic, is the distribution of terms. You'll recall when we did fallacies of ambiguity that we had composition and division, which were informal fallacies. So they're not rule-based. They're just kind of, we remember how we felt about that. So now we're going to try to have a system to properly describe distribution. And so this is the same concept, that whether we're talking about distribution or not. And so let's look at the definition. A term is distributed if the statement it is in. So that's the term it is in refers to every member of the class denoted by the term. And otherwise it's not. And we have a notational system where if it is distributed, it satisfies this definition, then we put a nice little flat line over the term as we're writing out the arguments, and we put a U for undistributed over the term if it's undistributed. And so with that, I'll walk through these distributions. So if you have an A-form statement, every A-form statement, this is not about generals, this is about the subjects of A-form statements. In this case, it's all subjects are predicates. The subject is distributed and the predicate is undistributed, okay? And as you're trying to assess distribution, you're trying to say, is the statement about every term? So all generals, yeah, it's definitely about all generals. Are we talking about every fool or only some? If it's only some, then you refer to it undistributively. So you put the U over top of it. So this is the concept that we're trying to understand. That does the statement refer to every single member of the set? Every single generals. There are some fools that are not generals, right? So we do not have every single fool. The E form, both the subject and the predicate are distributed. This is about every single truck and every single good truck. And notice the claim is there is no intersection of those two sets. So we're talking about the entire set of trucks, the entire set of good trucks, not the same thing. I-form distributions, we're only talking about some fish, and we're only talking about some of the predicate, in this case stinky. And so neither of those terms are distributed. And in the O form, some fish are not edible. Some clearly denotes that fish is undistributed. The term edible, why is that distributed? And this is probably the one that's not as obvious. And so let's talk about it a little bit. When we're talking, so the way this system works is some of the members of the category fish are not in the set of things that are edible. If you want to be super tedious and write it out in the most precise possible way, and notice we refer to the set of things that are edible. We refer to the entire set. And so whenever you have that sort of exclusionary reference, you are talking about the entire set. And so that's why that is distributed. If we want to try to summarize this in a way that's possible to remember, subjects of universal statements are distributed, so that's the A and the E. Predicates of negative statements, that's the no and the some are not. And everything else is undistributed. And I should have had my square of opposition back here. This was at the end of the last video. And you'll notice that we can start to put the distributions into that system. We'll bring that up again. In the text, we are going to skip over sections E and G. These are more direct inferences. Yeah. Let's say this, if you're planning to like write an university level entrance exam, an LSAT, a GRE or something, you might want to spend a little bit of time in that section of the textbook because for whatever reason, direct inferences are something they like to test for. It's pretty sketchy why, knowing Greek logic is the way to find out if you're going to be a good doctor or lawyer. Probably measuring privilege. Anyway, it doesn't really take us too far down the road of critical thinking, so I'm just moving on, okay? But everything else in Chapter 5 is assigned material except for sections E and G. And that's it for the third video on categorical logic. Thank you very much.